All right, so we're going to talk about security. Who here ever built an application where they stored passwords in plain text? There's 1, 2, 3. I'm sure there's more. Come on, let's face it. We all do it. I mean, Facebook did it. So why shouldn't we do it, right? So a lot of us do that as developers. Sometimes we have an idea, right? We have this like, oh, I'm going to build this new Uber of whatever, dog sitting or something, you know. And we get excited and we want to get started with our project. So first thing that you have to do is, oh, you need a login screen, right? So you start building your login screen, and then, oh, you need a sign-up screen so that users can actually sign up to your system, and then users. So you need a forgot password screen, and then next thing you know, you're like 2 weeks into your project, and you haven't done anything apart from the whole sign-up process. I think I have a few ideas on GitHub which are basically just that at this point. Like they're just there and it's just a sign-up screen because I got tired at one point and I lost interest. So, I mean, that's sometimes we take shortcut as developers. And at one point I did that and I heard about this thing called OAuth and I was like, it seems interesting. I think that might be something that will help me with this whole process and taking care of all that stuff because you know, I don't want to deal with all that stuff and securing the passwords and everything. So I looked into it, and then there's a lot of charts and arrows, and it's kind of complicated. The vocabulary is very dry. And yeah, I just went back to storing passwords in plain text because yeah, OAuth was too much trouble. Fortunately, they're not in production, just so you know. But yeah, and then eventually I got a job about 2 years ago, and it was at Auth0, and it's a company that has a platform, an authentication platform as a service. A great product, and their product basically uses OAuth, so I kind of had to learn it. So I actually went in and started looking into this and really digging into it and went past the whole like dry vocabulary and stuff, and I was like, oh, like this whole token-based authentication thing, that's like, oh, so cool. Like we should all use that. So this is what I'll try to introduce you today. I'll try to introduce you to those concepts by using a vocabulary that is a little bit more simple, and hopefully I'll convince you to use token-based authentication or OAuth as part of your future applications. So quickly about me, I'm Canadian, I'm French Canadian, more specifically, if you wonder where the charming little accent is from. I currently live in Toronto. I have a few videos on Udemy, Egghead, and stuff, so if you're interested in OAuth, a lot of videos are there. I work as a developer advocate for Red Hat, specifically for OpenShift, which is a orchestration platform that you can use to deploy your applications. Now, I've just started there, so if you have any questions about it, I can't help you, really. I can barely make my Linux computer work, so. So yeah, and I also co-organize Nomad.js. We do meetups online, so if you're interested in nomadjs.com, great website. Once a month, we have guest speakers that will talk about different things about JavaScript. Also, I love Twitter. I get really excited whenever I have Twitter notifications. I also make my own GIFs, so it's totally worth to follow me on Twitter. You'll see it in the bottom somewhere. It's Joel with 2 underscores, Lord. So feel free to follow me. I sometimes also post some smart stuff. And most importantly, I have stickers. Like that's the only thing that you need to know. They're right here. So at the end, feel free to come and get one. They're about my favorite topic at the moment, password hygiene. So passwords are like underwear. Feel free to pick one up. So I already said I work as a developer advocate. So basically what I get to do as a job for a living is that I learn about cool stuff, and then I go to conferences all around the world and I talk about it. Best job ever. I get to travel, I go everywhere, and back home, I mean, I'm a bit of a foodie. Like, I really enjoy good food. And actually, one of my close friends used to be a professional chef. Whenever we get together, right, we get like this amazing food. I don't like to cook, but I like to eat. And in my friend's perception, whenever I get to travel, they think that I go to all those fancy places. They're like, oh, you went to Paris. Did you go to this Michelin restaurant? In reality, most of the time, I usually run from one place to the other and I get meetup food or pizza. And because I travel, I don't necessarily always carry cash with me, because it gets complicated to have different currencies and so on. So typically I pay with a credit card. If you've been with me here in the last few days, you'll know that I'm really picky. I want to pay with my credit card and I want my check. I pay with my credit card because it makes my life easier. Of course, restaurants themselves, they don't know what to do with a machine, like with my credit card. If I hand that over to them, okay, I don't know what that is. They want money. So they use this device that you've all seen, which basically talks to a bank to kind of validate that I have money in my bank account. So what happens is that I go to the restaurant, I want to get my slice of pizza, and they say, well, you know what, we don't know what that card is, so here's that machine, which is basically an access to the bank. That machine will validate who I am using my card and a NIP, or a PIN, sorry, and then tell the restaurant that, yes, he does have 99 cents in his bank account, and gives me my slice of pizza. And that's what OAuth is all about. That's pretty much what it is. It's all about just delegating access to different resources. Of course, in the case of OAuth, we don't have a pizza, we have an API, and we don't have a bank, we have an authorization server. So you have a user tries to access some resources on an API. The API will need to validate if you are who you say you are, redirect you to an authorization server to validate that. And the authorization server's responsibility is to validate your identity. Once that is done, it will tell the API that, yes, you're good to go, and it will serve you the data. Really, that's all there is to it. Presentation done. Thank you. So, all right. But why would you do that, right? It's so much easier to make like traditional applications where you store your own username and password. So it's really all about delegation or passing the puck. Is that an expression, or is that too much Canadian? All right. It's all about passing the puck, or delegating access to different resources. So telling somebody, an authority will tell you, yes, he does have access to that resource. So that's what OAuth is all about. I've been doing software development for a few years now, as you might tell by my gray hair. And when I used to build applications back in the days, it was kind of easy. Like in 2000 or so, when I started doing PHP, don't boo me, but I used to do a lot of PHP. I saw the light and switched to JavaScript, but it was kind of simple. You have an application and it tries to connect, or you have a browser and the browser connects to the server directly. It was kind of easy. So you just request the login.php page, serves it back to you, and then you kind of enter your credentials, send that back to the server, validate against the database. Plain text makes it really easy to do that. And then, yep, you're good to go, and you just send a cookie back. The cookie would contain a session ID, which is basically just an identifier on the server to kind of say, yes, this is user X, this is Joel, and he has access to those resources. Very easy to use, made your life very, very easy. So why change anything, right? It was fun. It was fun. Software development was fun back then. In a world of stateless and RESTful applications, you can't really make it work that way anymore. There's a few reasons to that. First of all, we have all those devices connecting to our platform, right? You can't just assume that it's going to be a browser, a desktop, or a laptop. You have obviously mobile devices, and mobile devices can still deal with the login.php page like I used to do in my PHP applications. But what do you do with conversational UIs? What do you do with, how do you make sure that those can actually connect to your applications? So that was a bit of a problem. Then who did PHP here? Who's my age? If you've done PHP, you might, especially back in the days, it's a lot better now because it got more object-oriented, but back in the days, it was a nightmare. Your code would quickly become spaghetti, and you had all the best intentions when you started, but quickly it just became a real mess. So if your boss asked you to build another application, you pretty much had to start from scratch, because there was no way you were going to extract all the user logic out of it and reuse that code. So you just had to start from scratch. If you were lucky, you were able to reuse the same user database, but in most cases you had to start from scratch, new database. So your users would come into your websites, they knew that both websites were from the same company, but they had to create an account again and do all that process. If you want to connect to a third-party API, say you want your application to connect to your Twitter feed for some reason. Back in my days, what we would do, in the time of, what was it called, MySpace? So we would ask users to provide us with their credentials to the other API so that we could use those credentials in order to connect to that API. And of course, we needed those credentials to be stored in plain text because we needed to use them to connect to the MySpace servers. So you would be really careful about the user's credentials and store them and encrypt them, but then you would store their MySpace credentials in plain text in your database. And most of the time, they're the same credentials, right? So obviously that doesn't work, so we needed a mechanism to help with that. And finally, we already have a gazillion accounts, right? Who uses a password manager? You should all raise your hand. I have one. I've been using it for just maybe over a year now. And I have something like 350 different accounts in there. Like 350 accounts. That is mind-blowing. When you start using a password manager, you realize how many websites you have to sign up to. It's Medium, the blog. I don't want to create an account for Medium. I don't care. Like, I just want to read that post. Like every website asks you to create an account nowadays. And users are starting to lose trust a little bit in a lot of companies, and they've all seen that there is another password breach, and again and again and again. So they're starting to be a little bit more careful about sharing their credentials. So asking them to create a new account is not always a good idea. So that's where OAuth comes into play. So OAuth is a mechanism that basically just describes the flows of communications between different machines. That's pretty much all it does. It's not a very strict framework or protocol. It's kind of just, here's how information should flow between the different machines. That's pretty much all it does. Originally, all the big players, the big internet players were all like, okay, well, we should get together and find a way to exchange information between us. LinkedIn wanted to have access to your list of contacts so it could spam all of your contacts every time you logged in, right? And they all got together and they were like, okay, well, we should find a way to exchange information, but nobody really wanted to share how they did it. So they came up with this very, very loose standard. This is the way you would typically use OAuth in an application where you have a browser or a user connecting to a browser or a front end. You have a server that will serve the front end application, and the server will connect to a third-party API. You could see that as being LinkedIn, for example, trying to access your list of contacts on Gmail. It's a typical example. So the way that works is that your browser will start to connect to your API. The API will check, or the server will check, do I have access to Joel's list of contacts on Gmail? If it doesn't, it will redirect. Your browser will be completely redirected to the authorization server. And that full redirect is very important. I'll come back to that later. So once you're redirected to the authorization server will take care of validating your identity. Could be done in many different ways. Username and password, unfortunately, are still used. Could be biometrics, doesn't really matter. And then you send back a confirmation that the user is validated. And you will send back an access code to the browser. That access code is then sent back to the server. And the server will take that access code. It's just a little string. It's nothing, there's no magic there. It's just a tiny little string. And it will take that access code, send that to the authorization server, and the authorization server will be like, that's fine, I've issued that access code just a few seconds ago, so here's an access token. And the access token is the key to the API. That's what gives you access to the API. So I'll explain a little bit more about tokens in a few minutes, but what you need to keep in mind here is that the access token is really the key to the API. So any further request that the server will try to do to the API will always use that access token, and you'll be able to get access to different resources. You will also receive the access token is short-lived, so it has an expiry timestamp. So when it expires, you also have a refresh token, and you can use that refresh token to actually get another access token from the authorization server. So that's all nice, but in most cases, we don't have such a setup, right? Typically, a lot of applications that we build have a front end, React, Angular, whatever it is, and you try to communicate directly with an API, most likely an API that you've built yourself. So in those cases, the flow changes a little bit. So it's called the implicit grant. There's a lot of discussions about whether it's secure or not. If you're interested, I can discuss this into more details. But suffice to know is that it's still secure. It's still fine, just have to be careful about some very specific things. So in this case, your browser or your front-end application will be in charge of validating if the user is logged in or not. And if he's not, you do the same type of thing. You completely redirect the users to the authorization server, validate the identity, and then the front-end application will receive the access token. And I said the little thing you have to be really careful about is that this access token, I've already said it, but it's the key to the API. If you lose it for some reason, if somebody gets a hold of it, they can impersonate your users. So you have to be really, really careful about how you handle this access token. But then once you have it, you can actually access the data on your API, receive the data, and so on. The difference here is that you don't have a refresh token, so that's the main difference between the two flows. And you have to be careful, like I said, with the actual token. So I've talked about tokens. What are they exactly? So there's two types of tokens that I've talked about. There's actually three types, but let's focus on those two. There's an access token. Like I said, that's the key to the API. That's really what it is. It gives you access to different resources. And they're short-lived. They will expire after some period of time. The period of time is up to you as a developer to focus. Security is always gray zones. If you have an application like a financial application, a banking application, keep them very, very short, like maybe no more than 5 minutes. But if you have an application with no real sensitive data, you just want to validate that your users are connected, then maybe 8 hours is fine. And then you have those refresh tokens. And those refresh tokens, the only purpose for them is to get another access token. So those ones are longer lived, anywhere from days to months to infinity. And really, it's a key to the authorization server to get another access token. So why not make longer lived access tokens, right? So the whole magic happens here. The refresh tokens can actually be revoked at any point. So you might have seen this. This is on Google. You can see all the applications that you've used log in with Google. And when you log in with Google, you give access to another application. You give access to some of the stuff on your Gmail account or on your Google account. But at any point, you can remove or revoke the access to those applications. This is the screen from GitHub, which actually uses the same vocabulary. So there's a revoke button. So whenever you've connected using GitHub, you have this revoke, so you can remove the access. And that basically cancels the refresh token so that the application cannot get a new access token on your behalf. Tokens can take multiple forms. If you're into Microsoft WS federated stuff, not very familiar with. If you're into XML, SAML is a way to do it. But we're all here for JavaScript, right? So JSON Web Tokens are typically the way that is used in most modern servers now. JSON Web Tokens, oh yeah, I'd like to make just a little parenthesis here. So the spec says that they should be called JOTs. That's like the whole GIF thing, right? So it's not called the JOT, it's called the JWT. Let's make that clear. And I'm trying to convince enough people so that we can eventually change the spec so it doesn't say that it should be called a JOT anymore. And it's called a GIF, not a GIF, just so that we're clear. Okay, so JSON Web Tokens, they look something like this. Yeah, let's take a look at that. So there's 3 parts to it. So we can see that they are separated by a period or a dot there. The first part, the header, is this little tiny part here. Thank you. And yeah, it doesn't seem to make sense, but it's actually a base64 encoded string. So if you use the A to B function in your browser, you can actually convert that, and you will see that it's simply a JSON object. So you can take that JSON object, you'll see that this is an object of type JWT, and it uses the algorithm HS256 for the signature, which we'll see. So let's take a look at the middle part, the payload. The payload looks like this. Once again, kind of similar. So you can use the A to B function again, and you have a JSON object. The payload can contain anything. Just information that you want to carry around, that you want to share between the different machines that will use that JSON Web Token or that access token. There's a few reserved keywords, and they call them claims. A claims is just a key value pair. That's all it is. Some of the claims are reserved. Typically, those that have 3 letters are reserved keywords. So sub is subject, so who is this token about? So that's one of the reserved ones, so it's typically the user ID. There's EXP as well that is typically used, which is the expiry timestamp, and so on. Finally, we have the signature. The signature is not a base64 encoded string. It actually uses some sort of algorithm to generate a key or a signature. So in this case, I'm using HMAC 256 to generate a secret key. So you take the header, the payload, and you use the algorithm with a secret key, and that will generate a string that looks like this. The reason for the signature is to validate that nobody tampers with the JSON Web Token along the way. If you have to play with JSON Web Tokens, jwt.io is a great resource. You can take a look at this. You can just paste in your JSON Web Tokens. You have all the information on the right side, so it just decodes everything for you. There's also a bunch of libraries that you can use to encode or decode JSON Web Tokens. All right, let's look at some code. So that's readable, right? I wanted to show you like what would the most basic authentication server would look like. So the authorization server, essentially the only thing that it does is validate the identity of the user and then serves you a JSON Web Token or some sort of access token. That's all it does, really. I mean, it does get a little bit more complicated, but at its most basic level, that's what it does. So in this case, I'm using an authorization server. I use Express and body parser to read the content of the data that was passed. I will use the JSON Web Token library to create some JSON Web Tokens, and we can just start our Express server. There, I will have my user database with plaintext passwords, of course. And your Express server or your authorization server will basically have 2 routes. So first one will be a GET route, and it will serve just some sort of sign-up form. And it will have a POST route where you will submit the user credentials. And then a 404 for everything else. In your POST route, the only thing that you will do is that you will start by validating if this is actually a valid route, right? Or a valid request. So you'll check if there is a username and password as part of the request. If there is, you will check if you have a matching user in your database. And if you do have a matching user, you create a JSON Web Token. So this JSON Web Token library that I've shown you before is very easy. jwt.sign. You pass it the actual payload that you want to put in your JSON Web Token, as well as some secret key that you will share between the API and the authorization server. And then you redirect the users back to the original application. That's all you need to do. Then you can start the server, so that's it. Now you have an API, you want to make sure that the routes on your APIs are protected by that JSON Web Token. So you want to make sure that you actually require that key in order to serve the data on your API, right? So once again, I have an Express server. I use body parser. I use RandoPeep just to generate some random stuff here. And I use Express JWT, which is a middleware that basically what it does is that it will check if there is a JSON Web Token as part of the request, validate if it's a valid one, and then serve the data or send back a 401 if it's not a valid JSON Web Token. And then you start your server. To initialize your middleware, it's very easy to do. You just call the library. You give it a secret key, in this case, because I'm using HMAP 256. And then I have my two routes on my API. The first one will simply serve some random clickbait headlines. Just in case you haven't noticed by the title of my talk, I kind of like clickbait headlines. So I generate a random one here. And this one is a protected route, so a private route, so it also serves randomly generated clickbait headlines, but featuring yours truly in this case. So both routes are very, very similar here. The only difference is that in the second one, I'm using the middleware. I'm using the middleware in this case to validate if there is a JSON Web Token and if it's a valid one. And that's all you have to do for your API. On the front end, the only thing that you need to do is to add your JSON Web Token once you have it from the authorization server. You add it to all of your outgoing requests. So you just simply add this as an authorization header, and that's all you need to do. So let's take a quick look at what this looks like. Let's see if this will work. Huh, it works. Linux is amazing. Okay, so I've got my application here. And is everybody familiar with HTTP cats? They're so cool. Like, it's just cats that for HTTP goes. Anyways, all right. Fun. So I have my application here. I've got my two buttons for the two requests that I have on my API. So the first one is a public request, right? So I can just send my request, and it just sends me back a randomly generated clickbait headline. The second one is tries to connect to the protected route, and because I'm using the middleware in this case, it immediately throws me an error. No authorization token was found. And I get a 401 in this case. So let's try to connect to our authorization server. This is my very secure authorization server here. You might have noticed that the URL changed, so I'm completely redirected to another authorization server. And typically this would be a machine that you trust, not something that I built. And that's why you want to redirect them completely. The people that are building the authorization server would use a product like Snyk to make sure that there's no vulnerabilities in their stuff, and there's no keyloggers and all that stuff, and they will actually read the lines of code in your node modules folder, which I don't do. So from here, let's authenticate. Actually, if I don't put in a valid request, I'll get a 400. I just wanted to show that picture. Okay, so if I put in a valid request, I put in my username and password. Then I'm redirected back to my application, so I validate that the user is who he says he is, so yes, there's a good username and password combination. I'm redirected back, and I'm redirected with the access token here. So it's passed on as part of the URL. I can extract it and then remove it from the URL. And if I take a look at this with jwt.io, you can see the content. You can see that it has scope, which is typically the set of permissions. So in this case, I have access to read the API, the username, expiry timestamp, and so on. So now that you have this access token, you can now access the protected route on your API by passing this as part of the headers. So if we look at the network window somewhere in here, I'm not used to Firefox yet, once again, Linux. Oh, there it is. So right at the bottom, and nobody will see it, but basically it just says authorization, and it has the token here. So the only thing that has been done is that I've been passing that JSON Web Token as a key to the API, and I was able to get access to those resources. All right, easy peasy. So yeah, it's all about delegating access to resources, but it's also about delegating responsibilities to the people that actually care about it, right? In this case, the people that were working on the API, the only thing that they needed to do was to add this middleware. So you just need to add the middleware, and it will take care of validating everything for you. If you work on the front end, the only thing that you need to do is to pass on that header. So it makes it really, really easy. You don't have to do all those user checks and so on. So you can actually delegate all the security stuff to the people that care about it and that they are in charge of the authorization server. Why did I lose it? All right. So I said I travel a lot. And when I travel, of course, I need to stay somewhere. I need to find a hotel. Typically, I try to stay away from those shady hotels. Those type of hotels that actually just ask you to, write on a piece of paper who you say you are, and then people kind of disappear. So I usually stay at places that are, not that fancy, but kind of middle of the road. The first thing that they will ask me whenever I get there is to prove who I am, right? They'll want to make sure that they can charge me if I trash a room. So I could hand them over my passport, but a passport is a very sensitive piece of information. I don't want to give away my passport to anyone. I love Ukraine, but I want to get back home at one point. So I don't want to give away my passport. I could use my social security card. That's the official Canadian social insurance number card that I have. It's like the most useless piece of ID that you can have. Has nothing. It has a number and a name. It doesn't prove anything. And that's kind of interesting, because if you have that, that's not my number, just so you know. But if you use my social security number, you can actually get credit on my behalf. You can really steal my identity with that number. But that piece of ID is completely useless. It doesn't prove who I am. I used to live in Quebec, and that's the ID that I used to use all the time. And that's not mine, again. But that's the ID that I used to use, and I keep that one, even though I moved into the English part of Canada now. The reason is that it's in French, and it will be accepted anywhere in the world. And there's some reasons to that. Like it looks like a valid piece of ID. It looks like a driver's license. And even if you can't read French, you can kind of see that this is, an official ID. There's a bunch of things. There's like holograms. There's some sort of ID there. There's a name, date of birth, address. There's even a phone number that you can call to validate the barcode, all that stuff. Those barcode, one of the two, I can't remember which one, is actually used now. They have like an international standard. So if I go in the US, they can scan it to validate that I'm 21 if I want to get into a bar. So it is a piece of ID that gets accepted everywhere in the world. And that's pretty much what OpenID Connect is. So OpenID Connect is another standard, but it just sits on top of OAuth 2.0. So it's just an addition to OAuth. And the only thing that it does is to serve the identity of your users. So OAuth will take care of delegating the access to the resources, and OpenID Connect will take care of authorizing and providing the identity, so providing the information about the users, basically. So you will simply add a scope in your request. To get the information, you will need to specify a scope of OpenID, and then you can ask whatever information that you want about the user. So the way it works is that you will do your original request. You will add this scope permission to the authorization server. Authorization validates who you are. Sends back an access code. The access code is shared to the server. Server sends the access code. the access tokens is sent back to the server. And then the server will do an additional request to the user info endpoint with the access token, and the authorization server will send an ID token with all the information that you've asked for about the user. If you want to learn more, openidconnect.net is a great resource. Yeah, I have like 4 minutes left, so let's see if I can actually show you what it looks like. All right. So in this case, I will be, no, just ruined a bunch. Where is it? No. Oh, I missed my Mac. There it is. All right. So if I go back to my application, and now instead of using my own authorization server, I'll be using Auth0 in this case, but you could use any OAuth compliant server. Typically, like Google has one, Facebook has one, like all the major social media providers have one. So I can log in using my Google information. If I log in with my personal account, I will get that screen. We've all seen that screen, right? Nobody ever read whatever it says, but and we just click OK. But that's the OpenID consent screen. So it asks you, do you validate that you want to give access to your profile to that application? And you're redirected back to the application, the original application, the same way as before. And you have your access token, but you also have this ID token as part of your request now. So if we take a look at this is much more interesting. So if I paste it in jwt.io, you can see here that I have all this information about the user now. So in here, I have the name, so Joel Lord. It has my username, it has my picture in there. It's a bit small, but anyways, you get what it is. This is my locale, so I use French in Google for some reason, and so on. So you can see all of that information about the user. And that's great, because you don't have to ask the user about all that information now. Not only you don't need to ask them, but you don't even need to take care of that information. So if you have to build a GDPR-compliant application, you don't even need to store that personal information about your users. It's all on the authorization server. So it's not your responsibility anymore. All right, let's finish this. Come on. All right, so I've already said it many times, it's all about delegating, delegating access to resources, delegating the work to the people that actually care about it, but also delegating like all that stuff, all that security stuff. You don't have to take care of that. You can actually ask somebody else to take care of all of that stuff, and you don't need to do it on your own. So that's all I had for you today. So I'll leave you with this. Here are a few resources. I have a link that has all the information at the end. It's also going to be on Twitter in just a few seconds. So Joel with 2_ Lord, because yeah, you can definitely all read that at the bottom. So thank you.